Okay, in the interest of time and wow, there's an echo in this room. In the interest of time and also maybe just to give you direct access to the reading while the video is going on some of these things where it's just chatty and not so much calculations, I'm going to go through the text here with you so you can always just pause it and read this off the screen. We've already talked about sample. So sample, is from a population. A census is where you ask every person or every household. We talked about that before also. So if we really wanted to be 100% certain, we have to do a census. If we want to make a prediction, we're going to have some error. And so the differences that are just happening because we did a sample is called sampling error. It is sometimes called the margin of error. So we have bias, which we've talked about before. This is what you're looking for currently in your project. You're looking for what might have been a bias from a sample or a survey. So sampling bias, sampling frame is the group from which the sample is chosen. So if we wanted to know about people in our school, we could get the list of all the students, but that's not always even necessarily the case. So when you start out to choose a sample, if you have an incorrect sampling frame, that means that the group from which you chose your sample is already not representative. So if you wanted to find out something about people from Texas, all of Texas, by the way, for example, I don't know why I said by the way, if you wanted to, for example, find out about all the people in Texas, and then you just chose your sample from Plano. So you just took all the residents in Plano and then made some random choice of who to ask. Well, Plano is not representative of all of Texas, so you've got an incorrect sampling frame. So if a certain group of the population is not representative in the survey, so there would be a lot of people in Texas not represented if you just did a survey in Plano, then it's called undercoverage. Convenient sampling is what I was just talking about, really, because if you just choose Plano because you just live here, then you're convenient sampling. You're just picking what's easy. If you do a Facebook poll, if you stand outside a grocery store, anything that makes it easy for you but makes representation not good, that's a convenient sample. Judgment sampling is when someone who's considered an expert in the field being studied chooses who to look at. So if you're doing the survey, then maybe you're choosing. And so it can be a problem because you might automatically be drawn to certain people. So let's say that you wanted to poll all the shoppers at Walmart. And so you thought, oh, well, I'll just randomly choose people in Walmart, and then that'll be a good sample of the shoppers at Walmart. And I'll even go 5 different times during the day and go to 5 different Walmarts so that I get all this represented. But the fact is that you're still choosing who to approach. And there might be people that you don't feel comfortable approaching. You might be more comfortable with people your age or people of your gender or people of your race, various things like that. So then that ends up with a bias as well that was based on you making decisions. In quota sampling, what you would maybe do is say, okay, well, we're going to do this Walmart sample, but I happen to know that whatever percentage of people from Plano or this race or this gender or this age, and so you set up this thing where you say, oh, well, I'm going to make sure that 20% of the people I ask are whatever parameter you've decided is 20% in Plano. So let's say that 45% of Plano residents are female. And then you'd say, oh, well, 45% of the people I ask are going to be women. And doing it like that. So it's better, but you're still going to be drawn to certain people. So there's still a bias inherent in you choosing. That is, so size bias is something that could have happened in that same Walmart situation. So this one feels less biasy to me in a way, but basically if you were going to do a survey and the place where you were doing it had one of the subgroups that was very, very large, then that group, if you chose at random, would be more likely to be represented because there's more of them, which seems fair, but it's considered a bias anyway, a size bias. Then there's response bias, and response bias just generally refers to when people are offered a survey or a poll and they don't have to take it. So you have people who respond and people who don't. One of those is voluntary response bias. So that's when you kind of see a poll posted somewhere, somebody shares it on Facebook, they come on the AOL main page sometimes, and they say vote, and then you go vote, and then they show you the percentage that said this or that or the other thing. And the thing is that most people will not have a strong enough opinion about those polls to go vote. And so you have this bias of people who just don't, just flip past it and don't go vote. So it's a voluntary response bias because it's people just get to choose to respond. A non-response bias is when you actively try to get people to participate, not just post it, but they still don't respond. So people call on the phone and say, oh, we'd like your opinion about this, or see if you're satisfied with your, electric company or whatever. And most people just don't have time. Just say, I'm busy, I was about to eat lunch or whatever, and they don't respond. And I think I told you before about the survey that they sent out to biology teachers. They sent it to all these biology teachers asking them if they believed in evolution. And as far as that question goes, the more impassioned people are the people who do not believe. So they had a very low response and a very high percentage who said they did not believe in evolution. And that was not very representative of the population, but the people who did believe didn't consider it worth fighting for. So in both cases, you have this issue of passion, basically. How much do people care about the thing? Questionnaire bias is about the way the question is asked. We discussed this some when you did your surveys for Kaching, because how you ask something can affect how someone answers. If on Kaching you just had said, would you pay $1 for a candy bar, then most people would say yes without thinking, do I actually even want the candy bar, right? They feel like it's just, is this a reasonable price? So these questions, examples, do you believe that it is reasonable for the government to impose some limits on purchases of certain types of weapons in an effort to reduce gun violence in urban areas? More people feel that's a little bit vague and might say, well, yeah, that's reasonable. The effort seems like a good idea. And so even people who don't believe in gun control might say, well, yeah, that sounds okay. Versus, do you believe that it is reasonable for the government to infringe on an individual's constitutional right to bear arms? Because then people who believe in gun control would probably feel like, well, no, because you're telling me it's a constitutional right. So how you ask a question can affect how people respond. And so people who are going to go use those results in some argument or to try to affect some movement are likely to kind of twist the question around. But the other thing is that someone who is against gun control, the question, do you believe it's reasonable for them to infringe on your rights? That's how they view it. So they're giving their opinion within the question, and it then influences the responder. Okay, so incorrect response bias happens when people lie. So if you were trying to find out about, say, if we had a drug problem at our school, and so we did a survey to ask people, have you done X kind of drug in the past X amount of time? A lot of people would just say no because they're afraid they'll get caught, or they don't, that someone will know who did it, that it's really a trick, or else they feel embarrassed or whatever. So you get people lying about these things. If someone was surveying the general population to find out about, say, people cheating on their spouse, most people would lie about, or not most, some people would lie about that to anyone because they don't want to be judged by even the stranger. So that kind of thing is called an incorrect response bias. Okay, so then we have some examples which you could hopefully work through. So why don't you read the example, pause the video, see what you think, and then when you come back, then we'll scroll it up. Okay, so hopefully you've paused and come back now. You are assisting with a study attempting to determine the satisfaction of school communication with students who speak a second language. The plan is to send home a questionnaire to the parents of the students asking them about their opinion. What kind of bias in the survey is this survey method prone to? So you have a non-response and undercoverage bias because you've sent out a questionnaire. So if you ask people to submit a thing, you're automatically open for the non-response bias. And then the population who is most affected by the study is also more likely to be confused by the questionnaire because of the language issue. Okay. Example B, so pause this, try to determine the answer. Okay, so the first one, an experiment to determine the danger of mixing household chemicals, is conducted by collecting samples of chemicals found under the experimenter's sink. Mall shoppers are asked to fill out and return a form rating their shopping experiences at each of the 26 stores to identify the most popular stores in each of 4 categories. A study of average grades of mathematics student polls 16 Algebra 1 students, 14 geometry students, 7 calculus students, and 19 statistics students. Okay, so for A, you have a convenient sample there because the person just went under their own sink. So there's an undercoverage problem. With the second one, you have the non-response. The minute you said, would you mail this back, you're going to have some non-response bias even if you say, could you fill this out? I'm sure you've had that happen in the mall. Can we talk to you a minute? No, thanks, and you keep walking. But once you say mail it back, you've lost almost everyone. And then the last one is an undercoverage bias because of the 7 calculus students. But if this was a percentage each of those courses, then that would be the size bias. Okay, so we want to talk about randomization, about how to kind of control bias. And these are the kind of randomizations you're looking for when you read other people's survey results. If it shows randomization, then you can defend it a bit better. Okay, so the way we try to reduce bias is called sampling. I had to pause to save the thing, so I'm on a little different track here, but a simple random sample is best. And we've talked about these before also. So random means you chose in some random way where you didn't get to have a choice. So you could have said, oh, I'm going to take this list of people and I'm going to roll a die to determine which of the first 20 to start with, and then I'm going to skip forward 20 every time. And that would be random because any person was just as likely to be chosen as any other person. But for a simple random sample, you have to have any sample of size n is just as likely as any other sample of size n. So for those, you couldn't have done that because two people right after each other on the list could not have been in the same sample. So any sample with the two of them in it had no chance. So to be able to do that, you'd have to just kind of basically, it has to be equivalent to taking all the names and dropping them all in a hat and pulling some out. Okay, so the random function, it simulates randomness, but it's not true. Systematic sampling is what I was talking about before, where you randomly choose the first person and then you jump however many to get the right sample size. And even if you somehow scrambled up your numbers and then said, I'm going to roll the die and take the first whatever, it's still the case that people who ended up after each other can't be together, so it's still not. Cluster sampling is when you select a group at random first, and then you either take all those people or you randomly select from there. And then you can break your cluster into smaller subgroups as well, and then sample from each of them, which is multi-stage sampling. But if you start out by subsetting, it's called a cluster sample. So the example they give is if you're interested in, say, the whole state of Texas, then you could choose 5 schools at random, and then from each one of those, get a simple random sample. And that's multi-stage sampling. And if you wanted to do it for the whole nation, then you might first choose 5 cities and then choose from each of those a certain number of schools, and then from each of those randomly choose people, but so it's still all urban, so which is what they wanted, but I didn't mention it. But they wanted urban schools. So that's cluster sampling. Stratified sampling, that's how they tend to do like polls about elections, and also Nielsen Ratings does it this way. So what they do is they first divide into states, and then within the states they divide into regions, and the regions are divided into districts, and then for each district they find a group of people, and in the polling it's kind of random, but with Nielsen they choose people at that point, they choose them to match the population makeup. So if you have 38% white people in that district, they'll have 38% white people in their sample. So stratified sampling, then what they've done is now they still have, in some cases, a simple random sample. If they get down to, let's say they get down to the district level and they choose randomly, and they have a random sample per district, but it's not a simple random sample overall, because a simple random sample overall, if you were doing a sample of 1,000, you could pick 1,000 people from Dallas. They couldn't be in the sample together. But it's better if you're trying to represent a large area in a way to do it like this. so that you know you've got some people from each district in the sample. Okay, so this is the end of what I wanted to do for this video. This is just bias. At the beginning of the chapter, you'll see there are 4 parts here. And so I'm going to do, I guess, probably 4 videos. I'm not sure that central limit theorem needs its own, but I'll probably do 4. So I may try to do all those actually in the morning. So hopefully these will all be up pretty quick. But this is the only chapter for Unit 6. The confidence intervals are the kind of like heavy part, and you really need to understand those. You'll be using those also in chemistry. So I will save this and get this one uploaded, and then do the rest as soon as I can.